Hello. Hello students. Today we are going to study important problems in center of mass. What is center of mass? Center of mass of a system of particle is a point located either inside or outside the system. Hello students. Today we are going to study center of mass. What is center of mass? Center of mass of a point mass distribution system or a continuous distribution system is a point located either inside or outside the system at which complete mass of the system is supposed to be concentrated and at which vector sum of moment of masses remains equal to 0. Okay, this is the basic concept in center of mass. In reality, at center of mass, in physical sense, mass may or may not be present. And how to calculate velocity of center of mass? Velocity of center of mass can be written as m1 v1 vector plus m2 v2 vector divided by m1 plus m2. And in a very similar way, acceleration of center of mass also can be calculated m1 a1 vector plus m2 a2 vector divided by m1 plus m2. Let's start the problem solving. Two masses nm and m start simultaneously from the intersection of two straight lines with velocities v and nv respectively. It is observed that the path of their center of mass is a straight line bisecting the angle between the given straight lines. Find the magnitude of the velocity of center of mass. Here theta is the angle between the lines. Dear student, in the question this is theta. One particle of mass nm is moving in x direction, another particle of mass m is moving at an angle theta with velocity nv. Okay, we have to determine magnitude of velocity of center of mass. The formula which we will use here to calculate velocity of center of mass is m1 v1 vector plus m2 v2 vector divided by m1 plus m2. This formula we will use in x direction also, in y direction also. We will use the same formula. Okay, in x direction we will write the component in x direction, in y direction we will write the component in y direction. Okay, so let's start writing in x direction. The component of this velocity in x direction is what? Nv cos theta, and in y direction this is Nv sin theta. So without making component we can solve the problem very easily. See here, this is the particle of mass Nm moving with velocity v, and this particle of mass m is moving with velocity nv. We have to determine velocity of center of mass. So dear student, first we are calculating velocity of center of mass in x direction. This is what? Nm v plus, this is magnitude, velocity of center of mass in x direction, plus m into nv cos theta divided by m plus nm. This is velocity of center of mass in x direction. After solving this, we will get mm will get cancelled. This is nv plus nv cos theta divided by 1 plus n. We can take v as common. NV is common. This is 1 plus cos theta divided by 1 plus n. This is velocity of center of mass in x direction. This is magnitude of velocity of center of mass in x direction. Now, dear student, we will calculate in y direction also. This is in x direction. Now, we will calculate in y direction also. Okay. Velocity of center of mass in y direction magnitude nm 0 because it is having velocity only in x direction plus m into nv sine theta divided by m plus nm. After solving this, we will get will get cancelled, nv sine theta divided by 1 plus n. Okay. Now this is velocity of center of mass in x direction. This is velocity of center of mass in y direction. So we can easily calculate velocity of center of mass by writing Vx square plus Vy square. This will give us n upon nv upon 1 plus n. This we are taking common. In the bracket, this is 1 plus cos theta square. This is sine square theta. What you will get nv upon 1 plus n under root. This is 1 plus 2 cos theta plus cos square theta plus sine square theta. Dear student, cos square theta plus sine square theta is what? This is 1. 1 plus 1 is what? 2. 2 plus 2 cos theta. Okay. So this is nv upon 1 plus n. This is 2 1 plus cos theta. And cos theta can be written as 2 cos square theta by 2 minus 1. nv upon 1 plus n. And this is 2 1 plus cos theta. Cos theta can be written as 2 cos square theta by 2 minus 1 from trigonometric relations. Okay. Dear student, 1 1 will get cancelled. So we will get, this is 4 cos square theta by 2. So nv upon 1 plus n. This is 2 cos theta by 2. This is the magnitude of velocity of center of mass. And this is our answer. Okay. This is magnitude of velocity of center of mass. This is our answer. Okay. Now let's see this question. Two planks, each of mass m and length l, are connected by a frictionless, massless hinge as shown in the figure. Initially, the system is at rest and on a level frictionless surface. The vertical plank falls anticlockwise. The vertical plank falls anticlockwise and finally comes to rest on the top of the horizontal plane. Find the displacement of the hinge till the two planks come in contact. Okay. Dear student, since there is no external force in x direction, in this question there is no external force in x direction. When external force do not act on center of mass, position of center of mass do not get changed. So in x direction, position of center of mass of the system will not get changed. Now, dear student, when the hinge gets, when this vertical plane gets fall, okay, let us assume this situation comes into picture. We assume this to shift by x, okay. Since position of center mass will not get changed, let us take this as a reference point. So what is the equation? m1x1 plus m2x2 divided by m1 plus m2 equal to what? 2m L by 2 minus x, because we have assumed that this complete system is shifted by distance x, okay, upon 2m. If we solve the equation, we will get this is L equal to, after solving this, we will get m L by 2 equal to 2m L by 2 minus x. M will get cancelled. This is L by 4 equal to L by 2 minus x. So x is how much? X is L by 4. So dear student, displacement of the hinge till the two plane come in contact is L by 4. This is our correct answer and final answer. Okay. Now dear student, this is the common question which is usually asked in competitive examination. Locate the drawing given in the figure which has been drawn with ink of uniform line thickness. The mass of the ink used to draw each of the two inner circles and each of the two line segments is m. Its mass is m. Its mass is also m. And line segment mass are also mm. Okay. The mass of the ink used to draw the outer circle. Its mass is 6m. And the coordinate of the center of different parts are outer circle 0, 0, left inner circle minus a, right inner circle a, vertical line 0, 0, and the horizontal line 0, minus a. The y coordinate of the center mass of the ink in this drawing is. Now, since we need to calculate y coordinate, so we will apply formula ycm equal to what? M1 y1 vector plus m2 y2 vector plus m3 y3 vector plus m4 y4 vector plus m5 y5 vector divided by m1 plus m2 plus m3 plus m4 plus m5. Okay, in this way we can solve the problem. Now let's start. 1 2 3 4 5 things are there. This is our drawing. And this is center 0, 0. This is x direction and this is y direction. Okay. Now the mass of the outer circle is 6m. Okay, and its coordinate is 0, 0. Left circle and right side. This is located at A, means minus a plus a. This is plus a and plus a. Okay, and the vertical line, this is 0, 0. This is 0, 0. And the horizontal line, this is 0 minus a. This is the situation. Okay. Now it is very simple to calculate YCM. Dear student, what is YCM? For the circle 6m, this is 0 because its center is at 0, 0. Now for the left circle, mass m, this is a. For the right circle and for the vertical line, nothing, m0. And for the horizontal line, m minus a divided by 6m plus m, 7m, 9m and 10m. Dear student, if we solve this equation, ma and minus ma will get cancelled. So in the numerator ma is there, in the denominator 10m is there. So after solving, we will get YCM as a by 10. This is our answer. Okay. So answer to the question is option A. So dear student, we can tick option, we can mark option A as correct answer. We can mark option A as our correct answer. Okay. Now let's see this question. A man weighing 80 kg is standing at the center of a flat boat and he is 20 meters from the shore. He walks 8 meters on the boat towards the shore and then holds The boat weighs 200 kg. How far is he from the shore at the end of this time? The question is very simple. Since in x direction there is no external force, boat is there on the water, okay? Surface is frictionless. So in x direction, position of center of mass will not get changed. In x direction, position of center of mass will not get changed, okay? So we can solve the question very easily. This was the boat. And let us see, this is seashore. And this was the person. The person weight is 80 kg. The person position from the seashore is 20 meter. Now, and boat weight of the boat is 200 kg. And this is water. Now, the man is moving by distance of 8 meter on the boat. So with respect to boat, if we assume that boat shifts by distance x in rightward direction, okay? If it doesn't shift in rightward direction, then answer will automatically come negative, okay? So no problem. So don't worry about that. Let us assume x is the shift of boat in plus x direction. So we can write directly equation. In left side we are writing displacement negative 80 into 8 minus x. This is displacement of man with respect to ground, negative direction, okay? And this is displacement of boat in x. This is 200 into x equal to 0, okay? m1 x1 vector plus m2 x2 vector we have applied, okay, 0. Now we can easily solve the equation and can get the answer. This is minus 640 plus 80x plus 200x equal to 0. After solving this, we will get 280x equal to 640. Dear student, 0, 0 will get cancelled, and on solving x, we will get 64 upon 28. We are cancelling by 2, 32 upon 14, again 16 upon 7. After solving this, we will get 7 into 2, 14, 2, approximately 3. So this position is how much? This is, he has shifted by 8 meters. So 12 plus 2.3. So answer will be 14.3 meter. So dear student, answer to the question is option C. Answer to the question is option C, because boat has shifted by a distance of 2.3 meter in the forward direction, okay? So 12 meter plus 2.3 meter, that is equal to 14.3 meter, okay? Two blocks of equal masses M are released from the top of a smooth fixed wedge as shown in the figure. Find the magnitude of the acceleration of the center mass of the two blocks. Dear student, in the question, this is 30 degree, this is 60 degree, so this is 90 degree. We can assume this direction is x direction and this direction is y direction. This will remain very easy to solve the problem. This component of acceleration is how much? G sine 30. And the component of acceleration in this direction is g sine 60, okay? So dear student, now we can write the acceleration of center of mass m1 g sine 30 I cap plus m g sine 60 j cap divided by m1 plus m2. After solving this, we will get will get cancelled. G sine 30 means 1 upon 2 I cap. G sine 60 means what? This is g by 2 I cap. And this is how much? This is g by g root 3 by 2 j cap divided by 2. So this is g by 4 I cap plus g by 4 root 3 j cap. If we solve this equation, we will get acceleration of center of mass magnitude g by 4. We are taking common, under root 1 square plus root 3 square means 3. This is 2. So answer will be g by 2. So magnitude of acceleration of center of mass for this question is g by 2. Okay. Mr. Verma 50 kg and Mr. Mathur 60 kg are sitting at the two extremes of a 4-meter long boat 40 kg standing still in water. To discuss a mechanics problem, they come to the middle of the boat. Neglecting friction with water, how far does the boat move on the water during this process? Because the boat is on the water, now no external force is there in the x direction, so position of center of mass in x direction will not get changed. Okay, so you can easily solve the problem. This is the situation. This is the boat, this is 4 meter. This is 4-meter long boat. And the mass of the boat is 40 kg. Let us assume this is Mr. Verma. Its mass is 50 kg. And this is Mr. Mathur. Its mass is 60 kg. Let us assume the boat shift. Let us assume that the boat shift by a distance x right side. When Mr. Verma and Mathur comes at the center to discuss the mechanics problem. Okay, we have assumed x equal to shift of boat. In right direction. In right direction. Now we will apply our equation, common equation. This is 2 meter. This is also 2 meter. In the ground frame, because what we are assuming that the boat is shifting by distance x. So the displacement of Mathur in ground frame will be how much? 2 minus x. Displacement of Burma will be 2 plus x. Okay, now we can write the equation. Very simple to solve now. 50 into 2 plus x minus 60 into 2 minus x, because this is coming in negative direction, plus 40 boat mass into x equal to 0. Now we can easily solve and find the value of x. So this is how much? This is 100. This is 50x. This is minus 120. This is plus 60x. This is 40x equal to 0. Okay. Now we can easily find the value. This is 50x. This is 60x. This is 40. This is 100, 150x. This is how much? 100 minus 120 minus 20. This is 20. So x is how much? 2 upon 15 meter. Means how much? 200 upon 15 centimeter. If we cancel by 5, we will get 40 upon 3. That is approximately 13.3 centimeter forward direction plus x direction. This is the answer to the question. Okay. Dear student, this is very common question. A carpenter has constructed a toy as shown in figure. If the density of the material of the sphere is 12 times that of material of the sphere is 12 times that of cone. Material of a sphere is 12 times that of cone. Compute the position of center mass. If its density is rho, its density is given how much? 12 rho. Now we can easily calculate the mass. What is mass of the cone? M1. Volume 1 upon 3 pi r square. H is how much? 4r into rho. This is 4, 4, 16. pi r cube rho upon 3. This is m1. And now mass of the sphere equal to how much? m2. 4 upon 3 pi r cube into rho. This is 16 times, okay? 12 times. This is 48 pi r cube rho upon 3. This is 16 pi r cube rho. Now we can easily find, if we divide m1 upon m2, we can find what is m1 upon m2. 16 pi r cube rho will get cancelled. This is 1 upon 3. So m2 equal to what? m2 equal to 3m1. Means what? If its mass is m, its mass is how much? 3m. Now very simple to solve. Position of center mass is at r by 4, okay, h by 4. Dear student, now position of center mass ycm equal to how much? This is m into y, m1 y1. Y1 means h by 4. H by 4 means 4r upon 4. Plus m2 y2 means 4r plus r means 5r. Divided by m1 plus m2 means 4m. After solving this, 4 will get cancelled, will get cancelled. This is r plus 15r upon 4. This is 16r means 4r. This is the position of center mass. Means center mass will be located at this position, junction. Okay. So dear student, this is the solution for the question. The center mass is located at this junction. If the linear density of the rod of length L varies as lambda equal to a plus bx, compute its center mass. Since mass is variable, okay, so we will calculate center mass by integration method. What is linear mass density? There are three types of mass density used in question. Linear mass density means mass per unit length. Areal mass density means mass per unit area, and volume mass density means mass per unit volume. Okay. In this question, we are using linear mass density means mass per unit length. Okay. So, dear student, in this road, let us assume, suppose this is the length of the road, this is L, and mass of the road is M. Okay. And linear mass density is lambda. So, lambda equal to what? M upon L. We can write this dm upon dx. This dm is the mass of the element located at a distance x of length dx. Okay. So dm will be equal to what? Dm is equal to lambda dx. Okay. Now we can easily find xcm. What is xc? How to find xcm? Integration x dm upon dm. X bar is what? The x bar is the position of center mass of the element chosen. Okay. What is x bar? X bar is the position of center mass of the element chosen. Since x bar is x in this question. And what is dm? Dm is lambda dx. And what is lambda? Lambda is a plus bx dx. This is 0 to L. And dm is what? Lambda dx. Now we can easily solve. What is integration of x? This is a x square upon 2. This is b x cube upon 3. This is 0 to L. This is what? X plus b x square upon 2. This is 0 to L. After solving this, we will get, substitute the value. If you substitute the value, x square upon 2 plus bx cube upon 3 means a l square upon 2 plus b l cube upon 3 divided by a l plus b l square upon 2. This is position of center mass x direction. Now take L as common. This is a by 2 plus bl square upon 3 divided by a plus bl upon 2. Now take 6 as LCM. This is 3l plus 2bl square divided by 2a plus bl upon 2. So we will get, this will get cancelled by 3. So 3L plus 2BL square divided by 6A plus 2BL. This is the position of center of mass in term of A and B. This is the position of center of mass in term of A and B. Okay. This is the answer to the question. Now, dear student, let's see this question. A projectile is fired at a speed of 100 meter per second at an angle of 37 degree above the horizontal. A projectile is fired at a speed of 100 meter per second at an angle of 37 degree above the horizontal. At the highest point, the projectile breaks into two parts of mass ratio 1:3. The smaller coming to rest. Find the distance from the launching point to the point where the heavier piece lands. Dear student, to solve this question, one should know the simple concept of projectile. Since the projectile is getting break at the highest point, everyone knows at the highest point of trajectory, velocity of projectile remains only horizontal velocity. Okay. Let us assume mass of the projectile is m and its speed is 100 meter per second. So its velocity before breaking at highest point will be equal to how much? 100 cos 37 degree. Okay. This is how much? 100 into 4 upon 5. This is how much? This is 80 meter per second. This is before breaking. And what is given? A smaller particle coming to rest, means a smaller part will be here. This is, if the projectile could not break, if the projectile could have not been broken, then this could have been landed at a distance r. R means range of the projectile. The lighter part will fall here at r by 2. It is given in the question because it is breaking at the highest point. This distance is r by 2. Everyone knows. Okay. Now where the heavier part will lay? Let us assume the heavier part is landing at a distance x2 from point O. Okay. Now, dear student, what is range in this question? Everyone knows the formula of range. Range is what? U square sin 2 theta. U square 100 into r 100. Sin 2 theta 2 sin theta. Sin 37 degree 3 upon 5 cos 37 degree 4 upon U square sin 2 theta upon G. This is the range. If you solve this equation, you will get 0, 0 will get cancelled. 5, 5, 25, 25 means 4. So this is how much? 4 into 2, 8 into 3, 24, 24 into 4, 96. This is 960 meter. This is the range. And the projectile is getting broken in the ratio 1:3. 1:3 means one part is m by 4 and another part is 3m by 4. The m by 4 part is landing over here and 3m by 4 part is landing over here. Now very simple to calculate x2. Okay, because in x direction position of center mass will not change. Okay, so r will be equal to what? m1 x1. x1 is what? r by 2 plus m2 x2. This is m2 x2. This we need to calculate. Divide by m1 plus m2 means total m. So if we solve this equation, what is mm will get cancelled? This is r by 8 and this is 3x2 upon 4. This is r. So dear student, 3x2 upon 4 equal to 7r by 8. Again, after solving this 4, this will get cancelled by 2. This is r. So x2 is how much? x2 is 7r upon 6. Now if we substitute the value of r, this is 960. Okay, so what is x2? x2 is equal to 7 upon r into 960. If we cancel 6, this is 160. This is how much? 7 into 6, 2. And this is 1120 meter. So the heavier part will land at a distance of 1120 meter from the projection point. Heavier part will land at a distance of 1120 meter from the projection point. Okay. So this is the answer to our problem. Now let's see this problem. A dog weighing 5 kg is standing on flat boat so that he is 10 meter from the shore. He walks 4 meter on boat towards shore and then holds. The boat weighs 20 kg and one can assume that there is no friction between boat and the water. How far is the dog from the shore at the end of this time? Since in this question also there is no external force in x direction, so position of center of mass in x direction will not change. So we will use the equation of conservation of momentum and can solve the problem. See here, what is mass of the dog in this question? Mass of the dog is 5 kg. Okay, and mass of the boat is how much? This is 20 kg. And what is given in the question? The dog walks 4 meter on the boat towards the shore. Now displace later we have what we assume? We assume that during this process the boat has shifted by a distance x in rightward direction. What we assume? When boat has traveled by a distance of 4 meter on the boat, we assume that the shifting of the boat in rightward direction is x. So the displacement of dog in ground frame will be how much? 4 minus x, and taking minus x direction is minus x, plus x direction is plus x. So we can write taking leftward direction is minus x. Okay, so we can write equation 5 into 4 minus x. This is minus because we have taken leftward direction is negative. And now 20x equal to 0. After solving this, 20 equal to how much? 25x. So x is how much? 20 upon 25. 4 upon 5. This is 0.8 meter. Since the answer is coming in plus, so what our assumption is correct? This distance was 10 meters. So dear student, this distance is how much? This is 6 meter. Since the boat is shifted by a distance of 0.8 meter, so the position of dog from the shore, this is equal to how much? 6.8 meter. Position of dog from shore. When the dog has moved by a distance of 4 meter on the boat, this is the answer. Okay. Two blocks of masses 5 kg and 2 kg are placed on a frictionless surface and connected by a spring. An external kick gives a velocity 14 meter per second to the heavier block in the direction of lighter one. Deduce the velocity gained by the center of mass. The separate velocities of the two blocks in the center of mass frame just after the kick. Very simple question. See here. What is given? This block mass is 5 kg. This is connected by spring. This another block mass is 2 kg. Both are at rest, okay, connected by spring. Now external kick is given. External kick is giving velocity 14 meter per second. And its velocity was 0. Now velocity of center of mass will be how much? m1 v1 plus m2 v2 upon m1 plus m2, that is 7. So this will be 10 meter per second. This is in plus x direction, okay. Now what is being asked? Velocity gained by center of mass. So this is the answer of question A part. Separate velocities of the two blocks in the center of mass frame. Okay, in center of mass frame means what? The answer for part B. Velocity of 5 kg block in center of mass frame equal to velocity of 5 kg minus velocity of center of mass. This is equal to 4 meter per second. Now velocity of the second block of 2 kg in center of mass, velocity of 2 kg is 0 and velocity of center of mass is 10. So this is minus 10 meter per second. This is velocity of 2 kg, this is velocity of 5 kg, and this is velocity of center of mass. Okay. So dear student, this is the solution to our question. Now let's see. A block of mass capital M with a semicircular track of radius capital R rests on a horizontal frictionless surface. A uniform cylinder of radius small r and mass small m is released from rest at the top point A. See figure. The cylinder slips in the semicircular frictionless. We have to determine the shift of the wedge. Okay, what we have to determine? We have to determine the shift of the wedge. Very simple. Since in x direction there is no external force on the wedge cylinder system, So position of center of mass in x direction will not get changed. Position of center of mass in x direction will not get changed. Dear student, we can see this distance is how much? This is r minus r. Okay, what we assume? When the cylinder has reached here, what we assume? We assume let wedge shift by distance x in rightward direction. This we assume. Now we are applying equation of center of mass, okay, in x direction. What is xm? m1 x1. This is m1 r minus x. Not r minus x. Let us assume this to be in leftward direction. Then we can write in minus x in leftward direction. Then we can write this equation r minus x because the wedge has shifted by distance x. Okay, you can assume in right side also plus m into x because we assume shift in the leftward direction. So this will be minus x divided by m plus m. Now very simple to find. mr minus r minus x minus mx since this shift is 0, so what we can write m into r minus x equal to what? Mx. So m into r minus r equal to what? M plus m into x. So x is how much? M into r minus r upon m plus m. So this is the answer to the question. This is the answer to the question because position of center of delta xcm, this will be 0, okay? Not xcm. Delta xcm will be 0, okay? Two blocks of masses M1 and M2 are connected by a light inextensible string passing over a smooth fixed pulley of negligible mass. Find the acceleration of the center mass of the system when blocks move under gravity. Now, dear student, everyone knows when two blocks of masses M1 and M2 are connected, as shown in figure. What is individual acceleration of the blocks? This is M2 minus M1 upon M1 plus M2 into G. This is acceleration if m2 is greater than m1. Now we can write acceleration of center of mass equal to what? m1 a1 plus m2 a2 divided by m1 plus m2. You just substitute the value. Magnitude of a1 a2 are same. Just substitute the value. m1 a1 is how much? m2 minus m1 upon m1 plus m2 j cap plus m2 a2 value same, m2 minus m1 upon m1 plus m2 into g. This is minus jk divided by m1 plus m2. After solving this, you will get this value m2 minus m1 upon m1 plus m2 whole square g minus jk. So this will be the answer of the acceleration of center of mass. of the question. This will be the answer of the acceleration of center of mass. Okay, this is the answer. A car of mass capital M is moving with a uniform velocity v on a horizontal road when the hero of a Hindi film drops himself on it from above. Taking the mass of the hero to be small m, what will be the velocity of car after the event? Dear student, hero is coming from y direction. So in x direction, there is no external force. So in x direction, velocity of center mass will remain constant. This is the position. This is the position of the car. And this is the position of the hero. Okay, when the hero comes above the car, let us assume v dash is the velocity of car after the event. Okay, initially car is moving with velocity v. What is initial momentum? mv. What is final momentum in x direction? m plus m into v dash. So velocity of car after the event is mv upon m plus m. This is velocity of car after the event because there is no external force in x direction. Okay, so this is velocity of car in x direction.